Okay, folks, we are going to finish this chapter 3.8, which deals with direct, inverse, and joint variation. And without any further delay, let's get over to our notebook. And in our notebook talks about, again, direct, inverse, and joint variation. This is what 3.8 is about. You'll see it relates to our rational functions in a way that you're going to see as we develop through this. Let's start with the most basic one. We're going to talk about direct variation. Direct variation is something you've seen before. You haven't heard this term probably, but you've dealt with these type of functions. The form of the function when it's a direct variation is y equals k, where k is a constant. All right, so y equals k times x raised to the nth power. All right, you've seen these where we've had y equals 2x, y equals 3x squared, things of that sort. You've graphed all of these type. All right, so you have seen these before. The way we read this is y varies directly with x in its simplest form, if n is 1. If n is other than 1, we would say y varies directly as the blank of x. Now, when I say the blank of x, that could be the square of x, the cube of x, any power of x, basically. All right, so it could be a bunch of those type of things. All right. Now, when I say constant, this is in more complete terms. We call this the variation constant because we're talking about a direct variation. So when we talk about k, we're talking about that variation constant. All right. So that's your most basic one. I'm going to go through the three types and I'm going to show you how we use these in examples. Okay, so next we have, after direct variation, let's talk about inverse variation. How about that? All right, with an inverse variation. Now, when we talk about inverses, we're usually talking about 1 over something, right? So that's going to stay the key here. We're going to have our x in the denominator. This is of the form y equals k, still a variation constant, but now it's going to be over x to the n. Or you can think of it as k times 1 over x to the n. I've also seen it written this way. However you want to think of it, this is a direct, or I should say an inverse variation. I've actually seen this written also, just to bring it up in case you ever see it. If you have this, that is also a form of a inverse variation. So how do we use, well, what does this mean? When we read this, we say y varies inversely as the blank again of x, and that'll just be a power of some kind. All right, so again, same type of format, just a little bit different because we're talking inverse here rather than direct. All right, finally, we have one left, and that is a joint variation. And joint variation is a little more freeform because it's using more than one variable. And the basic form of a joint variation is going to be y equals k, again, the variation constant, excuse me, times x to the n, z to the n. Now, I want you to know this could take a lot of different varieties. We could say y equals k times x to the n over z to the n, where we have a direct variation with x and an inverse variation with z, or vice versa. This can get moved around. What it basically means when we say a joint variation, we're talking about more than one variable. All right. And so again, this could take a lot of forms. And the way we talk about this is we say, when we read this, if, let's see, well, let's just not put an if in there, I'm sorry. If we just put y varies jointly, whoops, jointly with the, again, blank of x, and you could also, well, and I'm going to put this, and the blank of z. But you could have also varies jointly with, say, the cube of x and inversely as the blank of z. Again, this doesn't have to be there. It could be just varies jointly with the with x and z, and then it's just this. If it's y varies, this would be y varies jointly with the nth power of x and inversely with the nth power of z. All right, so again, it could take a lot of different, I hate to say variations, but it could take on a lot of different variations. All right, there's different ways we can piece these together with a joint variation. All right, so now let's look at some examples. And yes, I prepared these for you. All right, y varies directly as x, and y equals 45 when x equals 2.5. So they've told us a couple things here. So if we want the form y equals kx to the n, and they want us to write an equation of this form, they've given us x, and they've given us y. So they're saying 45 equals k times x. When it says varies directly as x and it doesn't give us a power, we have to assume x is to the first power. So x is 2.5. So in other words, we get 45 equals 2.5k. And all we're solving in order to write this equation is we have to solve for the variation constant. In order to get the equation, to complete an equation, you have to solve for the variation constant. All right, this seems to be something that messes people up when we get to a quiz, is we ask them to write the equation, and they'll write the equation with k still in there. And that's not what we're looking for. Solve for the variation constant. All right, so, and I don't want 45 and 2.5 in there. I want x and y in there, but I want k solved for. All right, so I need to solve this first. So I'm going to divide both sides by 2.5. And I get k equals, let's see, if we do 45 divided by 2.5, that's 18. So k equals 18. And that means our answer for this would be y equals 18x. And that's it. That is our equation. It says write an equation of this form. That is an equation of this form. X and y are still general. We solve for our k. So we found with this example, we used it to find k. We've got our equation. So that was the key there. We wanted to write the equation. All right, let's keep moving. Y varies directly as the square of x. All right, so right off the bat, I'm thinking y equals kx squared, right? Y varies directly as the square of x. That's just interpreting that to be this. And then they told me y is 30. So now I'm going to start replacing. They did not give me a k. X is 4. Find x when y equals 270. Well, there's two steps to this. I need to first find the equation. All right, so I need to find the equation first. That's step one. And then plug in y. All right, so first part is find the equation. So I need to do this. 30 equals 16k, and I divide everything by 16. And I get k equals, well, 30 over 16 is what, 15/8, I believe. Right, so let's call that just that, 15/8. And, well, I'm sorry, k equals 15/8. So we have our equation. Our equation is then y equals 15/8 x squared. And now it told me this is step 2 in this equation. In this problem, they said find x when y is 270. So first thing, I got my equation. And I believe in the problems we have on the quizzes, we ask you to write the equation. So this is what we'd expect you to write. And then we say find x when y equals 270. So finding x when y is 270, well, now I can plug in 270 equals 15/8 x squared. So now to solve for my x, I first have to multiply both sides by 8/15. All right, and when I do that, I get, let's see, that's going to be 144 equals x squared. And then I take the square root of both sides. And so x is going to equal, there's two possibilities, plus or minus 12, right? So we have two possible solutions here. X could be both 12 or negative 12. And we've answered the question. So we've got the equation, then we get the question. We answered what it asked us to solve for. All right, so let's keep moving. If y varies inversely as x, all right, immediately is when I read that sentence, I always try to interpret it right away. Y varies inversely as x. So I'm going to do it this way. And y is 14, so now I can plug in 14 equals k over when x equals 3. And x, when it says varies inversely as x, I know n is equal to 1, right? So this is just going to be over 3. And we need to solve. So we need to find x when y is 30. So the next thing I need to do is solve for k, right? I first need my equation. And for that, I need to solve for k. So multiply both sides by 3. And when I do that, I get 42. So 42 equals k. That means my equation is y equals 42 over x. And it told me find x when y is 30. So I have 30 equals 42 over x. And again, remember when we have this situation, what can we do to solve? Right? What we can do is switch these two. So I can say x equals 42 over 30, which is, what is that? That's going to be 21 over, I'll just do this quickly, and then that's 3, that's 7 over 5. So that would be 7/5. All right, so we have our equation. Well, let's look at what that would look like. Our equation then is y equals, now this is where you have to be aware. If I have 7/5 over x, isn't that the same as saying y equals 7 over 5x, right? Because this is saying 7/5 times 1 over x, right? So that would be 7 over 5x. And that would be the form of our equation. So now, that was step 1. We got our equation. Y equals 7 over 5x. Now, step 2, it said, I'm sorry, that was step 2 already. We got our equation when we were right here. Then we solved for when y is 30. I'm sorry. I went off on a tangent here, guys. Sorry. We found that x was 7/5. We did both of them. I just kept going thinking I was solving for the variation constant still. I apologize. So 7/5. And then, so we've got that, right? X is 7/5. All right, let's see what else we got. Let's do another example. If y varies jointly as x and the cube of z, and y is 16 when x is 4. So again, right off the bat, y varies jointly as x. So y equals kx and the cube of z, so z cubed. And y is 16 when x is 4. So now I can start plugging in. 16 equals k times x is 4 and z is 2. So we got that. All right, so that tells us 16 equals k times 4 times 8. So 16 equals k times 32. So k is 16/32 or 1/2. So we know y equals 1/2 x z cubed. So we've got our equation. First step is done. Equation. And our first step is done. So now we can solve. It says for the second situation, find y. So we're trying to look for y when x is -8 and z is -3. So we have, I'll call this -4 for these two, times -27 And so y is going to equal, what is that? 54, 108. So that is going to equal 108. And we've solved for y when x is -8 and z is -3. So we got our equation and we got our answer. All right, so again, the three different types of variations, direct, inverse, and joint. You're going to need to be able to manipulate those in solve form. There's also a section in here, and I think it's valuable, is this idea of interpreting or saying what something is. All right, so for example, what I mean by that is if I gave you the area formula for a circle, you guys all know this. This seems to be the one everyone remembers. Area is pi r squared. What kind of variation is this? This is a variation, right? This says that area varies directly as the square of the radius. I got to go down here. Right? That's what that means. And what would be our variation constant? What's K? Well, K is pi. So again, these formulas, a lot of them that you've known for a long time, are examples of these variations, right? And you're going to be asked to do this in the book. They're going to ask you to take they're going to give you something like this and say, write out in words what kind of variation this is. So again, area varies directly as the square of the radius is how I'd explain that. And then they're going to say, what is the variation constant? Well, K is pi in this case. All right, so just one other way of kind of reversing this process. All right, and that's it, guys. That's all we have for direct, inverse, and joint variation. You're going to have some examples to work on, and we will answer your questions tomorrow. Have a wonderful day.